Hello everyone, welcome to my channel. Today in this part I am going to discuss with you introduction of Pythagoras theorem. Now before we begin with the Pythagoras theorem, let us understand what is the uses of Pythagoras theorem in real life. It is used in architecture and construction. It is used in laying out square angle and navigation as well as in surveying. Now before we begin with the Pythagoras theorem, I'll explain you what is right angle triangle, the term related with the right angle triangle, properties of right angle triangle and Pythagoras theorem. And most important, I am going to show one activity to prove Pythagoras theorem. So without wasting any time, let us start our chapter. So before we start Pythagoras theorem, let us learn about right angle triangle. Now we know that right angle triangle means a triangle where one of the angle is 90 degree is called right angle triangle. Suppose this is a triangle A, B and C. In a right angle triangle, one of the angle is 90 degree and some of the other two angles are 90 degree. So we can say that angle A plus angle C equals to 90 degree. Now the side AB and BC, these two sides are called as a legs of the right angled triangle. Now look at the angle 90 degree. The side opposite to 90 degree is called as hypotenuse. We are going to represent it as H. Now this side AB and BC, these are known as the perpendicular. We are going to represent it as P and BC as base B. So Pythagoras theorem deals with the right angle triangle. So just a recap of the fact, the side opposite to 90 degree is called hypotenuse and other two sides are known as the perpendicular and the base. Now hypotenuse is the longest side. This is the hypotenuse and it is the longest side of the triangle, and this is the shortest distance to reach A from the point C. Suppose if you want to reach A and you are starting from C, so you can go to C to B, B to A. In spite of that, you can directly move from C to A. So hypotenuse is the longest side of the triangle, but it is the shortest distance between the point A and C. So AC is the shortest distance from A to C. So now moving into the Pythagoras theorem. What is the statement of Pythagoras theorem? Pythagoras theorem states that in a right angle triangle. So first I am drawing a right angle triangle. Suppose this is a triangle PQR. Q is 90 degree. So in a right angle triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides. Now this is the hypotenuse, this is perpendicular, and this is base. Pythagoras theorem states that the square of the hypotenuse, that means PR square, equals to PQ square plus QR square. That means sum of the square of perpendicular and base is equal to square of the hypotenuse. Am I clear to everyone? Now you know one interesting fact. This idea of this theorem was proposed by one of the Indian mathematician, Bodhayan, long back before Pythagoras proposed his theorem. What he states? He states that the diagonal of a rectangle produces by itself the same area as produced by its both sides. Now, if you check the statement of Bodhayan, what he proposed? He proposed that I am drawing a rectangle. Now, if we draw a diagonal, then diagonal divides it into two right angle triangles. Now, look at the statement of Bodhayan. Bodhayan states that the diagonal of a rectangle produced by itself the same area. That means if you consider this length diagonal and make a square where one of the side is equal to the length of the diagonal, then the area of that square is equal to area of the square, sum of the area of the square whose length are length of the rectangle and breadth of the rectangle. I'll explain this in detail when I am going to show some activity to prove the Pythagoras theorem. So, isn't it interesting that Indian mathematician already proposed the same concept much before what Pythagoras theorem states in the later half. Now, moving into the next part, converse of Pythagoras theorem. Converse of Pythagoras theorem means it is the same statement in the other way round. If you recall the Pythagoras theorem, it states that in a right angle triangle, that means to apply Pythagoras theorem, you need a right angle triangle. Now, the converse of Pythagoras theorem states that if you find that in a triangle, suppose ABC is a triangle, and if you find that sum of the square of any two sides, that means AB square plus BC square, if you find that sum of the square of any two sides is equal to square of the third side, then the triangle must be a right angle triangle. Clear? In a triangle, so look at the statement, in a triangle, if square of one side is equal to sum of the square of other two sides, then the angle opposite to the first side, is a right angle. So that means this theorem, converse of Pythagoras theorem, required when we are going to prove whether a triangle is a right angle triangle or not. Let us check out one example. Now, if you see this example, The side of a certain triangles are given below. The sides are given as 60, 20 and 12. 16 centimeter, 20 centimeter and 12 centimeter. For example, we named it as AB, BC and CA. Now, so AB square equals to 16 square. 16 square, that means 16 into 16 is equal to 256. BC square equals to 20 square, that means it is 400. And CA square equals to 12 square, that is 144. Now, if you add these two sides, that means if you add AB square plus CA square, you will get 400. 256 plus 144, 400. 400 is equal to BC square. Now, if you see, it satisfies the Pythagoras theorem. That means this is a side of a right angle triangle. This is a side of a right angle triangle. Now, BC is the 20 square, which is the longest side. Now, if you draw the triangle, so you need to name it as BC because hypotenuse will be the longest side. So this will be 20. And which angle will be the right angle? So opposite BC, A, that means A will be the right angle. So in this way, we can prove whether a triangle is a right angle triangle or not. And look at the number 16, 20, 15. 16, 20, 12. These three numbers satisfy the Pythagoras theorem. So these numbers are known as Pythagorean triplet. The number which satisfy the Pythagoras theorem is known as Pythagorean triplet. One such example is 3, 4, 5. 3 square plus 4 square equals to 5 square. So 3, 4, 5 is one of the Pythagorean triplet. Another example is 6, 8 and 10. 6 square 36, 8 square 64. If you add 36 plus 64, you will get 100, which is equal to 10 square. So 6, 8 and 10 is another Pythagorean triplet. Find some of the Pythagorean triplet, write in the comment box. Let's see how many numbers we can find which makes the Pythagorean triplet. Now, before we going into the second part of this video, let us solve one more problem. It is given that triangle ABC is right angle at vertex A. So whenever you solve geometrical problem, for better understanding, draw the diagram. So vertex, right vertex at A, so A, B, C is a right angle triangle. We need to calculate the length of BC. We need to calculate the length of BC, where AB is given as 18 centimeter and AC is given as 24 centimeter. Now see, this is a right angle triangle. So we are going to use Pythagoras theorem. So if you apply the Pythagoras theorem, so this length, that is BC, will be the hypotenuse. Why? It is side opposite to 90 degree. So we can say that BC square equals to AC square plus AB square. Now substitute the value of AC and AB. So we'll get 24 square plus 18 square. So BC square equals to 24 square, that means 24 into 24, 576, and 18 square equals to 324. That means BC square equals to 900. Now see, the value of BC square is 900. We need to find out the length of BC. That means we need to take a square root of the number. Now what is the square root? Square root means we need to find a number which when multiplied by itself will give you 900. So we say BC equals to square root of 900. This is a sign of radical. This is a sign of radical. Now how to find out square root of 900? How to find out the square root of 900? Those who are in the higher classes know how to find out the square root of 900. But for my younger children, let me explain you how we are going to find out the square root. Now we need to find out the square root of 900. What we need to do, break this number into its prime factor. 900, 3, so 900 can be written as, this is a sign of radical or the square root. So in place of 900 you can write 3 into 3 into 2 into 2 into 5 into 5. Now make a pair of same number. Make a pair of same number. This is one pair. This is another pair. And this is a pair of 5. Now from each pair, one number will come out. So 3 into 2 into 5. So 3 2 is 6, 6 5 is 30. So square root of 900 is 30. So let me recap the process. Whatever the number, you need to find out the square root. You need to express the number as its prime factor, product of prime factor. Make a pair of the same number. I am making a pair of 3 and 3, not 3 and 2. You need to make a pair of same number. And from the number, you need to take out individual number. From the pair of 3 into 3, I am taking out 3, 2 into 2, 1 2, 5 into 5, 1 5. And once I am taking out the number from the pair, I am not using the square root sign. So with this knowledge, you can solve the problem based on Pythagoras theorem, because in each of the sum we need a concept of square root. Let's move. So you see, square root of 90 is equal to 30. So we can say that BC equals to 30. So we got another Pythagorean triplet, 18, 24 and 30. 18, 24 and 30 satisfy the Pythagoras theorem. So these three numbers forms a Pythagorean triplet. So I hope you understand the basics. Let us move into the next segment, which is activity based on Pythagoras theorem. So in this section, I am going to prove Pythagoras theorem using one activity. Now for that, you need to draw a right angle triangle considering any of the Pythagorean triplet. Here I am taking this right angle triangle as 3, 4 and 5. 3 square plus 4 square equals to 5 square. So this is a right angle triangle. Now this is one square whose length of one side is equal to 4. This is another square whose length of one side equals to 3. And this is third square whose length is equal to 5. That means there are 3 squares corresponding to 3 sides of the right angle triangle. Now what I do, I take a cutout of the right angle triangle of the same measurement and I'll try to fix it in this region. Now this is a square whose length is b. Symbolically I am representing a, b and h. So I placed it in this place. Now this is the third square which I am going to place here. And this is the last square whose length is 5. So I am going to place it here. Now what I going to do, the Pythagoras theorem states that the area of this square should be equal to the area of this square plus this square. So next what I am going to do, I'll remove this square and try these two squares and try to fix it here. So now what I am going to do, I am going to fix it here. Now this space, this empty space, I am going to fill with this square. Now I cut the bigger square into small pieces so that I can paste it here. So I paste it here. Next part I am going to put it here. This part I am going to place it here, and the last part I am going to place it here. So now you can see that what is the Pythagoras theorem. It completely covers the square whose length is equal to the length of the hypotenuse. Hence it proves the Pythagoras theorem.